Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chanapkot. Dear students, in the previous class we were discussing about what is temperature, heat energy, what is heat transfer, what are the modes of heat transfer, and what is the equation to calculate the different modes of heat transfer through different modes. In detail we have discussed, and also we discussed some major fields which are using heat and mass transfer, and what are the application of heat transfer. In detail we have discussed. Dear students, come today we'll move towards next topic. Okay, so next topic is modes of heat transfer. Dear students, in the previous class also I told you there are three modes of heat transfer. One is conduction mode, conduction heat transfer, convection heat transfer. Third one is radiation heat transfer. So heat transfer is going to happen in three ways: conduction, convection and radiation. So to understand that conduction, convection, I have taken one day-to-day example and I try to explain you the modes of heat transfer. So if the conduction is nothing but what? Heat transfer. It is going to take place in a solid body where the molecules or atoms are at under rest. That is conduction heat transfer. Whereas convection heat transfer is a mode of heat transfer in which heat is going to transfer from one system to another, one part of the system to the another part, or one system to another system due to molecular motion. That is known to be convection heat transfer. Whereas radiation heat transfer is a mode of heat transfer in which heat is going to transfer from one part of the system to the another part, or one part of the substance to the another part of the substance, where there is no any media at all, but the heat is going to transfer in the form of electromagnetic wave. That type of heat transfer we are going to call it as a radiation heat transfer. Dear students, come today we will discuss in detail what is conduction, convection and radiation heat transfer. So now to understand conduction, convection, radiation, try to understand these modes of heat transfer by taking some live example. Okay, so first I will take an example, a man sitting on a table here now. Then what actually happening, dear students? Now the heat which is generated by a body, right, or human, is going to transfer from body to the surrounding or from system to the surrounding. Okay, then how it is transferring? That heat is nothing but what? Heat transfer we are going to represent it as a Q. That Q is going to transfer in three ways. One is that heat transfer is going to happen in three ways. One is conduction, second one convection, third one radiation. So third one radiation. Fine. So now you can, dear students, somewhat evaporation, sweating will happen, right? Then because of your overheat or excess heat in your body, sweat will happen. Due to that sweat, what will happen? Evaporation. So that means what? Heat is going to transfer from your body to the surrounding through evaporation. That type of heat transfer you can call it as a convection heat transfer, dear students. One thing, and also if the air is there, right, if your body is overheated, then air is the ambient air, atmospheric air. What it will do? It will come and it is going to interact with your body surface. Then what happens now? Your body is high temperature, say example 37 degrees Celsius. Ambient air temperature is 20 degrees Celsius. Then air will come freely and it is going to interact with the surface of your body. Hence what happens now? Your body is going to transfer excess heat to the air, hence air will come out. That means what? The heat is going to transfer from your body to the air, where the air molecules or atoms are at under motion. Due to this molecular motion or atom motion, you have removed your excess heat to the surrounding. That type of heat transfer we can call it as a convection heat transfer, dear students. One thing, and when you are sitting on a bench, right, because of this physical contact of your body and bench, then what actually happening now? Some amount of your body heat is going to transfer to the bench. That heat transfer you can call it as a conduction heat transfer. Because of physical contact, during that physical contact, the molecules are at rest. Those molecules, what they will do? They are going to transfer heat from high temperature region to low temperature region. That type of heat transfer you can call it as a conduction heat transfer. Okay, now we understood what is conduction, convection, heat transfer. Now third one is radiation. Dear students, in this there is no any physical contact of your body and there is no any media, fluid media, but heat is going to transfer from your body to the surrounding. That third type of heat transfer we are going to call it as a radiation heat transfer. Dear students, what is radiation heat transfer? Radiation heat transfer is a mode of heat transfer in which heat is going to transfer from your body to the surrounding where there is no any fluid medium, one thing, and that heat is going to transfer in the form of electromagnetic wave. That type of heat transfer you can call it as a radiation heat transfer. This we can take, dear students, one example. Second example, dear students, you can see when we are doing jogging, right, in early morning, then what happens? Little bit 7:30. Okay, so what happens? When you are running, right, what happens? Your body temperature is going to increase. That means what? Heat is going to generate in your body. Then that excess heat, what you have to do? We have to transfer that excess heat from your body to the surrounding. Dear students. Now what happens now? We can see here, dear students, 1 minute, that whatever the excess heat is generated in your body, right, that Q, you are going to transfer to the surrounding. How it is then? That we can see here now. When you are going to sweat, right, that sweating, through that sweating, what actually you are doing? You are transferring your excess heat of your body to the surrounding through evaporation or sweating. That is something about convection heat transfer. One thing, when you are running, right, you are breathing more. Okay, when you are breathing more, you are doing more respiratory action. Due to that, what happens? The hot air from your mouth is coming and it is going to enter into the surrounding. That means what? You are transferring heat from your mouth to surrounding. Again, when your hot air is coming, right, that hot air is moving. That hot air is going to come out from your body and that hot air is going to mix with the cold air which is there in the atmosphere. Hence what happens? The heat is going to transfer from hot air to cold air. If the heat transfer takes place in that manner, that type of heat transfer you can call it as a convection heat transfer. Hence respiratory or evaporation, both are what? Convection heat transfer, dear students. One thing, when you are running, right, in the garden or in the yard, right, then what happens? The air is coming freely and it is going to interact with your body and it will absorb certain amount of heat, that excess heat, and it will come out. Again, what happens though? Heat is going to transfer from your body to the surrounding air. Here what happens? Because of the air molecules, because the air will come, they will move and they are going to interact with your body, they will absorb the heat and they will come up. Because of air molecular motion, the heat is rejected from your body to the surrounding. That type of heat transfer you can call it as a convection heat transfer, dear students. Okay, fine. One more thing. When you are running, right, the blood circulation is going to happen, right? That blood is going to circulate from your heart to all parts of your body. Then when it is blood is there, right, the blood heat is going to generate. That blood, what it is going to do? Okay, so that blood molecules, what they will do, dear students, they will absorb certain amount of heat at high temperature region. Then that blood molecules move somewhere else and they are going to transfer heat to the some other parts through blood motion. That means what? Blood cells or blood molecules. If the heat is going to transfer by blood cells, that type of heat transfer you can call it as a convection heat transfer, dear students. One thing. Okay, next, again that blood cells, what they will do? Hot blood cells, what they will do? They will transfer heat to the muscles. How they were going to transfer? They will move. The blood cells will move from high temperature region to low temperature region, that is muscle you can call. Then heat is going to transfer to the muscles with the help of a blood cells movement. If it's so, if the heat transfer takes place in that manner, that type of heat transfer you can call as a convection heat transfer, dear students. One thing. Next, you can take when you are running on the earth surface, right, your foot is there here, right, then it is physically contact with the earth surface. Already your body is excess temperature, say example 39 degrees Celsius, the earth temperature is 20 degrees Celsius. There is a physical contact between your leg and earth. Okay, then what happens now? The heat is going to transfer from your leg to the earth surface. That type of heat transfer we can call it as a conduction heat transfer. Conduction heat transfer means what? The heat transfer is going to take place in physical contact with your leg and earth surface. But the molecules are not at all there. They are not at all moving. Because of physical contact and molecules are at rest, the heat is getting transferred. That type of heat transfer you can call it as a conduction heat transfer, dear students. One thing. Then solar radiation. Now, when your excess heat is there, right? If the excess heat is transferring from your body to the surrounding, if there is no any fluid media, Okay, if the heat is transferring in the form of electromagnetic wave, that of heat transfer we are going to call it as a radiation heat transfer, dear students. What is radiation heat transfer now? Excess heat of your body is transferring from your body to the surrounding, but there is no any fluid media and there is no any physical contact, but heat is transferring in the form of electromagnetic wave. That of heat transfer we are going to call it as a radiation heat transfer, dear students. One thing, and whenever the radiations which are going to fall onto the earth, right, some amount of energy is going to reflect. That is nothing but what? The heat is going to transfer from earth surface to somewhere else, but there is no any media, there is no any physical contact. If the heat is transferring that fashion, the top of heat transfer we are going to call it as a radiation heat transfer, dear students. So this is one of the best example you can take to understand what are the different types of modes of heat transfers are there in our day-to-day life, dear students. Okay, now so we can get like that we can get n number of application of conduction heat transfer, radiation heat transfer and convection heat transfer that I have listed here, dear students. Cooking, you can take conduction heat transfer, conduction heat transfer, convection heat transfer and radiation heat transfer. You can get n number of application of different types of heat transfer that I have listed here, dear students. Okay, fine. Now like that, so this already I have discussed how it is radiation, conduction. In previous class also I have discussed. These are what application of different modes of heat transfer. Heat is getting transferred, but it may be in the form of conduction, or it may be in the form of radiation, or it may be in the form of convection. These are what application of heat transfer, dear students. Okay, now I will move towards next topic, that is conduction heat transfer. Now we understood, yes, we have seen a number of application of heat transfer. That heat transfer application may be conduction, convection or radiation. Then what actually conduction? What actually conduction? Definition we understood, dear students, but now we'll try to understand conduction heat transfer in detail. Okay, come. What is conduction heat transfer? Dear students, conduction is a mode of heat transfer in which heat transfer is going to take place through a material by direct contact of particles. Conduction is a mode of heat transfer in which heat transfer is going to take place due to physical contact of particles in the same material. That is known to be conduction heat transfer. How it is, dear students? To understand that conduction heat transfer, I will take an example here now. I will take a metal wire. Okay, then I will with the help of one heat source, you can call it as heater or heat source you can take. Then what I will do, I will heat in a metal rod. That metal rod is nothing but what? You can take aluminum rod is there, or aluminum wire you can take. I am going to heat that aluminum rod or wire at one end. Then what happens? The heat is going to transfer in this fashion. This becomes what? Heater is the high temperature region that I can mark it as 0.1, or the temperature at this side I can mark it as a T1. The heat is going to transfer from 0.1 to 0.2. What is 0.2? 0.2 represents cold region. 0.1 represents high temperature region. Heat is going to transfer in this way, but that heat is transferring in a metal wire. But in the metal wire, how it is transferring? Heat is going to transfer from one part of the substance to the another part of the substance, where the molecules or particles, they are having physical contact each other. Those molecules, what they will do? They will absorb heat and they will pass on to the next molecules, but those molecules will be at under rest only. They will not move at all. If the heat transfer takes place in that fashion, that type of heat transfer we are going to call it as a conduction heat transfer. Conduction heat transfer is nothing but what, dear students? When you are going to take a metal wire, it is having in molecules. Those molecules, they are going to transfer heat from one part of the system to the another part of the system, or one system to another system, where the molecules will not move, but they may vibrate or they may jiggle. If the heat transfer takes place in that fashion, that we are going to call it as a conduction heat transfer. How it is that we can see, dear students? To understand that conduction heat transfer, we can do one experiment. What is that experiment, dear students? I will take a lamp here. I will take a lamp here. Then I will take a aluminum rod, or you can take aluminum wire. Then what I will do? I will fix an iron nails held with the wax. In a wax, what I will do? I will put an iron nails and I will put on to the aluminum rod. Then I will try to supply heat at one end. This is 0.1. You can take it as a 0.2 or one end and second end. Then what happens now, dear students? When you are going to heat the aluminum rod at one end, right, the heat is going to transfer from this one end to another end. That means once the heat is getting transferred in a solid aluminum rod, right, the molecules what they will do, we will pass the heat from one point to another point, but they will not move, but they will not alter their position, but they are going to transfer heat, but they may vibrate. So heat is going to transfer like this, it will come to this point. So then what happens once the heat reaches this point, right, that's whatever the wax is there, right, that will melt, and the nails whatever it is there, it is going to fall down. Then what we can experience that heat is transferred from point 1 to point A, you can call. Similarly, again keep on adding heat, then what happens, the heat is going to reach point B. That means what, second nail which is held with wax, right, that is also going to fill. That means what, the heat is transferred from point A to point B. Again, how it is transferring, through a metal rod or aluminum rod, that is because of molecular interaction or physical contact. Like that, what happens now, heat is going to transfer from one end to the another end, or one part of the system to the another part of the system in a solid body where the molecules are at rest. That type of heat transfer you can call it as a conduction heat transfer. That conduction heat transfer can be calculated with the help of an equation. That equation, Q is equal to minus Ka into dt by dx. This equation is given by Fourier, a scientist. Joseph Fourier has given this equation, and that law, whatever he has given one law, that is law towards the conduction heat transfer. That law popularly we will call it as a Fourier's law of conduction. That law is nothing but what, Q is equal to minus K into dt by dx. This we can call it the Fourier's law of conduction or Fourier's law of conduction equation. So how it is, what is that Fourier's law, that I will discuss in upcoming classes in detail. Okay, to determine how much amount of heat is transferred from this point to this point, I can calculate with the help of a Fourier's equation, that is Q is equal to minus K into dt by dx. Okay, fine. So dear students, you can see now, we can take a live example. When in cooking in your home, right, assume that you are going to supply heat to the metal pot here now. There is a metal pot that is having in a plate here now. That plate I can say here now. You can take it here now. So I am heating at one end, then heat is going to transfer from this end to this end in a metal plate. The heat is transferring from this end to this end with the help of molecules or atoms which are present in that plate. That molecules, what they will do, they will absorb heat from high temperature region, then they will pass on to the low temperature region. They will keep on transferring the heat, but the molecules will not at all move. If the heat transfer takes place in that manner, that of a heat transfer you can call it as a conduction heat transfer. One thing, and you can put in a metal spoon here. Dear students, assume that water we have taken into the pot, that water is heated to 90 degrees Celsius. Then what happens now? Or then when you are keeping metal spoon into the hot water, then what happens? The heat is going to transfer in this fashion. So after some times, if you try to hold it here, it is very difficult for you to hold, because you are going to experience the heat. So that means what? Heat is transferred from this point to this point in a solid metal spoon. That type of, if the heat transfer takes place in a solid metal spoon, that type of heat transfer can be called as a conduction heat transfer. That conduction heat transfer can be calculated with the help of this equation. This is what conduction heat transfer, dear students. This is a live example you can feel. Next, so what is conduction heat transfer, dear students? Just recall, conduction is what? Is the mode of heat transfer. Okay, so conduction is transfer of heat from one part of substance to the another part of the same substance, or from one substance to another in physical contact with it, and without appreciable displacement of molecules forming the substance. That means what, dear students? Conduction is a mode of heat transfer in which heat is going to transfer from one part of the substance to another part of the substance, or one part of the system to the another part of the system where the molecules are at under rest. That type of heat transfer we are going to call it as a conduction heat transfer, dear students. Okay, so you can say in your home, as I told, dear students, when the heat is going to transfer at the bottom of the plate in your cooking, right, that heat transfer we are going to call it as a conduction heat transfer. So that I have taken here cross section or cut section view to understand that you can see, and that area of that plate also play a very important role, dear students, while calculating the conduction heat transfer. That is A. That A is nothing but what? Area which is perpendicular to the direction of heat flow. That's what I have shown this figure. Fine. Now, dear students, I was telling atoms are atoms or molecules are at under rest. What is that actually? That you can see here now. So when it comes to conduction heat transfer, dear students, is the transfer of heat from one part of the substance to another part of the substance. Dear students, one part of the substance to another part of the system. What are the red molecules or atoms? They are the high temperature regions. They are hot molecules, we can say. These hot molecules, it's a metal body, yeah? So it is aluminum rod, dear students. In the aluminum rod, what I will do, aluminum rod, what I will do, I will take a molecules here. Molecules or atoms you can take. These hot molecules, what they will do, they are physically contact with the cold molecules. Then what will happen? The heat generally, he is going to transfer from hot molecule to cold molecule. But this molecule, what it will do, it is physical contact with the cold molecules, hence the heat is going to transfer. Sometimes these molecules may vibrate, but they will not move at all. They are transferring heat from high temperature region to low temperature region. They might vibrate, but they will not alter their position. The type of heat transfer we are going to call it as a conduction heat transfer. So leave it for small time. Then this heat is going to transfer from hot molecule to cold molecule or hot atoms to cold molecules. Then second series, the second also becomes hot. Next, keep on, heat is going to transfer from again here to here. The next, after sometimes whole metal rod is going to get heated. That means what? The molecules wherever they are there, right, they are in the same position, but the heat is going to transfer from high temperature region to low temperature region. That type of heat transfer we are going to call it as a conduction heat transfer. To experience this, we are going to have an experiment, dear students. Now, as I told, dear students, I will keep a lamp here. Okay, so when I am going to supply certain amount of heat, that heat is represented as a Q. Heat is moving in this direction. So I can call it as a high temperature region and I can call it this side as a low temperature region. This molecule, what it will do, first set of molecules or atoms in the aluminum rod, they will absorb the heat. Then what will happen? They are physically contact with second set of molecules. Then what will happen? The heat is going to transfer in this fashion. Okay, next these molecules become hot. Then these molecules, what they will do? They are going to transfer it to the next. Then again, next this molecules or atoms becomes hot, then this becomes cold, and hence what happens? The molecules, they are going to transfer heat from this to this. But these molecules, all molecules, they are not at all moving. They are not at all moving. They may vibrate little bit, but they will not move, but they will not alter their position. But they are going to transfer heat from one molecule to another molecule. That type of heat transfer can call as a conduction heat transfer. Once the heat transfer reaches here, right, then the iron nails held with the wax, right, that wax is going to melt. If the heat is transferred here, right, then what happens? That nail is going to fall down. Okay, you can call it as a point A. Then next again, what happens? It is fall down. Okay, heat is transferred up to here. Now this molecules get heated, next gets heated, next heat is going to transfer these molecules. Once the heat is transferred to these molecules, right, then what happens? The again iron nails which are held here with wax, then what happens? The wax is going to melt, hence the iron nail is going to fall down. That means what? Heat is transferred to this particular point B. Like that again, point C, like that also third nail is also going to fall down because of the conduction heat transfer. Hence what we can say, once the nail falls down, right, then what we can say, the heat is transferred to that particular point due to heat is going to transfer in a metal. Okay, that where the molecules are at rest only. That type of heat transfer you can call as a conduction heat transfer, dear students. So to calculate the conduction rate of conduction heat transfer, we are having an equation. To understand that equation, just I will take a metal plate here now. Dear students, I am going to heat metal plate at one end. So I am going to supply certain amount of heat to the metal plate. That amount of heat supplied is represented as a Q, and the area of the metal plate I will take it here as a A, and that metal plate having some thermal conductivity I will represent it as a K, dear students. Now what actually I am doing here now, heat I am supplying this side. That means what? When you are seeing at a side view, you can see this is point 1, this is point 2. Heat is moving in this direction, right? Point 1 to point 2. Temperature of the plate at point 1 is T1, temperature of the plate at point 2 is represented as a T2. So when the heat is moving in this plate, right, there will be some resistance in the flow of heat. There is a resistance in the flow of heat. That resistance is represented as a R. Then that resistance resistance and variation in temperature I can represent in a circuit. That circuit I can call it as a thermal circuit. How it is then, dear students? When it is at this particular point, right, the temperature is T1. Then when it point 2, right, it is T2. Temperature at point 1 is T1, temperature at point 2 is T2. When the heat is transferring in a plate, right, there is some resistance. That resistance is represented as a R. These all temperature and resistance I can show it in a circuit. That is nothing but what? Thermal circuit, dear students. What is the thermal circuit? You can see here, dear students, now. So initial point is T1, the temperature of the metal plate at high temperature region, because heat is moving in this direction. Then when heat is moving, right, there is some resistance. That resistance I can mark it here R. That R is nothing but what? L divided by Ka, dear students, now. Okay, then heat is moving. That movement of heat is represented as a Q. Then it is going to reach point 2. That point 2 having different temperature. The different temperature I can mark here as a T2. With the help of this temperature and resistance, what I can do, and resistance and plate thickness, okay, and area of the metal plate and thermal conductivity, I can calculate the rate of heat transfer or amount of heat transfer for unit I can calculate. That is nothing but Q. So with the help of that equation, easily I can calculate the rate of heat transfer. Q is equal to minus K into dt by dx, where K is nothing but what, dear students? Thermal conductivity, where A is nothing but what? Area of the plate or object. dt is nothing but change in temperature, that is T1 minus T2. dx is nothing but what? Thickness of the plate, dear students. That is dx. We can dx, thickness of the plate. You can take L or dx, it's up to you. Then unit is joules per second. Energy transfer per unit time, joules per second. That 1 joules per second is equal to 1 watt, dear students. This is what? Conduction heat transfer. Okay, so next class I will discuss about convection and radiation heat transfer. Dear students, I hope you understood today's class. If you understood really, if you like my videos, if you are supporting my effort, please do like, comment and subscribe my channel for such a more and more videos. Thank you.